Hello my dear 10th class students, I welcome you to NEET WORLD. So in this session we will be discussing about acids, bases and salts, and this is lecture number 3. Particularly here we will be discussing about bases, and then next we are going to discuss about acid base theories, which are very important for all our upcoming higher session classes, as well as if you are preparing for JEE and NEET from now itself. So this concept, basic acid base theories, are very useful, and in order to understand your 11th class topics also, this session will be helpful. Okay, so just watch till the end, and I also have one more request. Just click on the like button before we are starting the session, so that it will really boost us to do more videos. Okay, so let's start here. What exactly bases? So bases are the substances which have bitter in taste. Okay, so they are having bitter taste and soapy touch. Okay, and they turn this red litmus to blue color. Okay, red litmus to blue. Okay, you need to remember this. So bases turns red litmus to blue. Okay, this is what we have seen here. Okay, and then next, whereas acids will convert blue litmus to red. Okay, this is what the things you need to remember. And here what are the other changes will we see? See, some color changes shown by various indicators with bases. So when we add an indicator to this base, what are the color change we may seen here? We will be discussing about that. Okay, so what are indicators? So these are weak organic acids. Indicators are either weak organic acids or weak organic bases, which upon adding two acids and bases, they will show their color. They will show some color change in their ionized form and unionized form. They will be having different colors, so that depending upon on the one in which we are adding, so it will be varies from one color to other color, so that we can indicate the given substance as acid or base. For example here, when we add phenolphthalein, so this phenolphthalein is a weak organic acid. What I am saying, it is a weak organic acid. So I have shown you the structure and how it will be showing the color in acidic medium, basic medium in the last session, right? So if you haven't seen, just go and watch after this particular session. Okay, so now what I am saying, phenolphthalein is a weak organic acid. Okay, now in when it is in when I am saying it is weak organic acid, so I am just writing it as a symbol as HPH. Okay, so this is a symbol to indicate the phenolphthalein. Okay, just take it as a simple one. It's having a very big structure. You can watch in the previous video. Just to understand, let us take in this manner. Okay, so now when it is in this manner, like in unionized manner, so it will be a colorless one. So what I am saying, it is a colorless. Okay, so it is a weak organic acid now. So when we keep this phenolphthalein into the basic solutions, for example NaOH is a sodium hydroxide, is a base. So when we add this phenolphthalein indicator to that base, so here I am taking NaOH, or any base you can consider here, base you can just write base. Okay, so now what we will be getting is, so this H plus ion is taken by this base, so that we will be getting pH minus. It means this phenolphthalein is getting ionized now. Okay, negative form of anionic form of this phenolphthalein is formed. Okay, now it will be having some color. Okay, therefore the colorless solution now converts into color, like pink color it will be showing. Okay, so this is what the change we will be observing when we add a phenolphthalein indicator to the basic solution. Okay, so when we add phenolphthalein to the base, it gives pink color. Okay, you should remember this point. Similarly, when we add methyl orange, it gives yellow color. Okay, you need to remember this. Okay, then next, when we add base to the blue litmus paper, there is no change in color. If we take blue litmus solution, if we add base to the basic medium, or if we add this blue litmus solution, there will not be any change. Why there is no change? Because blue litmus won't react here. Only red litmus converts into blue color, whereas blue remains unchanged. It will remains same. Okay, it won't get affected here. Okay, so that is what the points you should remember here. Okay, whereas red litmus converts into blue. This is what the change you will need to remember when it comes to the bases. Okay, hope it is clear and very simple to understand, right? Now what are the observations we can do when we add some acids, some bases while taking different indicators. So in the first case I have taken litmus paper, like red litmus solution, then next blue litmus solution, and phenolphthalein indicator and methyl orange indicator. Okay, so let me change some colors here. Yeah. So what I am doing is, so HCl, hydrochloric acid we have. So when we add this to the red litmus solution, so when we add red litmus to the red litmus solution, no color change, na? Because so if we add acids to the blue litmus solution, it will convert into red. But if we add directly to the red litmus solution, there is no color change. So for all these acids, see, for this acid there is no color change, because here there is no change for red litmus solution. Okay. Now where if you add the same thing to the blue litmus solution, yes, that converts into red color. See, it is converting into red color. Hope it is clear. Now when it comes to phenolphthalein indicator, so phenolphthalein indicator, again what I told you, weak acid, na, weak organic acid. Now these are acids, again this is also acid, so there is no reaction between them. There is this H plus ion is not taken by these acids, because they are also releasing H plus ion. Okay, therefore there is no reaction between phenolphthalein and these acids, so no color change with the phenolphthalein indicator. You can remember, that is what the colorless solution will be seen, even if we add phenolphthalein indicator to the acids. Okay, hope it is clear. Now if we add this weak like methyl orange indicator, which is a weak organic base, now it will be converting color from like orange color to pink color or red color. You can say red color. Okay, so where to where? So orange to red. So this change will be seen in case of methyl orange when we add acid. Okay, or if we add to the acid solution, if we add methyl orange, we will be seeing a red color. So this is a transformation we will be seeing when we add methyl orange indicator to the acids. Okay, now well, let us discuss about these bases. See, here we have bases. Now red litmus converts into blue in this case, right? And if we add this to the base, if I add blue litmus solution, there is no color change. So no color change here we have seen. Okay, so it indicates these are bases. Okay, now phenolphthalein, what we discussed just now. So in the last slide we discussed in here. So what happens? We will be getting a pink color solution. So that is what. So when we add these bases here, it will be forming a pink color solution. And when it comes to methyl orange, the color change here we will be seeing is yellow color. Okay, so orange color converts into yellow color. This is what the thing you need to remember here. Okay, now what is like, let us have a comparison between acids and bases. Let's their properties for acids, bases, let us compare. Okay, so taste for acids it is sour, and for bases it is bitter. Okay, and the next feel. So there is no characteristics feel for acids, but for bases we told that it is having soapy to touch, right? Next, litmus test converts blue litmus to red for acids, and this is reverse, red to blue. Okay, now phenolphthalein, it is colorless in acidic medium and pink color in basic medium, and methyl orange here it will be in red color. Okay, red or pink here they will be saying, and here in basic medium it will convert into yellow color, right? Then next, reaction with metals. Yes, so acids upon reaction with metal gives hydrogen gas and salt is formed. One best example we discussed is zinc metal upon treating with acid like HCl. So what will be getting? ZnCl2 plus H2 gas is released. Okay, I hope it is clear. So in the reactivity series we have studied now in displacement reactions. In the last class also I have explained about this kind of reactivity series, right? So in the reactivity series, the elements, the metals which are at the top of the series will be highly reactive, and they will displace the like hydrogen gas from the respective acid and forming like salt of that particular metal. Okay, so this is what happens. For example, if we take magnesium, we will get magnesium chloride plus hydrogen gas. Hope it is clear, right? Next, reaction with metal carbonates. Okay, and when it comes to bases, it won't show reactions generally. Okay, there are some exceptions, but generally we are talking no reactions, you can say. Okay, so now reactions with metal carbonates. So what we can get? So we can get CO2 gas, salt and water is produced. Yes, we discussed in the last session about this thing also. And for bases, no visible reaction. Okay, so now pH value. So what is this pH? So there is a scale in order to express the strength or concentration of acids, or the strength of an acid. We are saying it as pH scale. So in this we will be having values from 0 to 14. Okay, so from 0 to 14 means mid value is 7 na? So from 0 to 7 we can have acidic medium range. So this is acidic range, where 0 like minimum number starts as strong acid, as the number increases it becomes weak acid, and 7 is a neutral, and again here as the number increases it basic nature increases, 14 is a maximum, that is what the strong basic region. Hope it is clear at 25 degrees Celsius, whatever I told you, that is. Okay, so now hope it I think, see what is this pH? So pH scale is used to express the concentration of H plus ion, right? So how much like strength an acid will be showing. So what, whether the acid is weak acid or it will be having strong nature or weak nature. So so we will be expressing using the value of this pH. Okay, so weak acids will be having the range which is near to 7 but below 7, and strong acid will be having value lower value like towards 0. Okay, like 2, 3, 2, 1 like that will be having, that is what for strong acids. Okay, and for strong bases it is near 14, and this discussion is completely at 25 degrees Celsius. Okay, and then next, so what are the examples of acids? We have sulfuric acid, hydrochloric acid, acetic acid, and HNO, the nitric acid. These are the example, and these are NaOH, KOH, CaOH. These are the examples for base. Okay, color in universal indicator. So it will be converting red to orange. Okay, and here blue to violet. Okay, you can remember that. Okay, so what are the ions released in the water? So acids will releases H plus ions in the water. Okay, we will discuss about that in the next slides. Okay, just hold for some time. Okay, and bases will release OH minus in the aqueous solution. Okay, and then next, these are the uses. So uses cleaning, digestion, preservatives, dyes will be using this acid. Okay, and bases will be used in the soaps. Okay, antacid, neutralizing acids. So in order to neutralize the acid, we will be using bases. Okay, we'll discuss about this very clearly. Just hold for some time. Okay, next, reactions of acids and bases. So what is this process called? So reaction between acid and a base is called neutralization reaction. The reaction between acid and base will gives what? Will gives salt plus water. Okay, and the process is called neutralization reaction. Here we have an example. So HCl, which is acid. Okay, and upon treating with NaOH, which is a base, okay, we are getting NaCl salt, which is stable salt we are saying now. So this is what? Salt plus water is formed, H2O. Okay, this is process is called neutralization. Okay, so now what is the pH of this resultant solution? Just now I told now about pH scale. So resultant solution will be having, so equal number of moles of acid and base is taken. See, 1:1 ratio we have now. So now completely converting into respective salt plus water is formed. So pH of this will be around 7, which is neutral solution. Hope it is clear. If we take more quantity of acid, then a resultant solution will be having some amount of acid. Therefore, what happens? Resultant solution will become acidic only. And if resultant if we take base as more quantity, excess quantity, what happens? After reaction, some amount of base will remains unreacted, so that will make the solution to show basic nature. Hope it is clear. And in this case, pH value will be greater than 7, right? Okay, let us discuss few more things. Some other examples of neutralization reaction. See, here we have carbonic acid, so H2C2O3, which upon reacting with KOH. Okay, so here we have 2 H plus ions now. From carbonic acid, it releases 2 H plus ions. Therefore, for each H plus ion require each OH minus, so that H plus OH minus. Okay, from base. So overall it will be forming H2O, right? So like that 2 H plus ion require 2 OH minus. That's why for each 1 mole of carbonic acid, we require 2 moles of KOH, potassium hydroxide. Therefore, it will be neutralized and forming K2CO3, potassium carbonate, and water is formed. Okay, Hope it is clear. Next, sulfuric acid, again here also 2 H plus ions are there. So for removing each H plus ion, we require 2 OH minus ions. I mean, for one sulfuric acid, there are 2 H plus ions it is releasing, right? So that it means from each NaOH, see for NH4OH or NaOH, you can take anything here just for our understanding only. So one NH4OH having only one OH minus ion to release. Therefore, for 2 H plus ions, we require 2 moles of, see for each 1 mole of sulfuric acid, we require 2 moles of ammonium hydroxide. Therefore, it will be completely neutralized like this, okay, and forming ammonium sulfate and H2O is formed, okay. Hope it is clear how we are writing these equations, okay. And you know the resultant solution, what we have, ammonium sulfate and water. See, ammonium sulfate, this is a salt, okay. So this is a salt made up of strong acid. NH4 H2SO4 is a strong acid. So in the next session I will be explaining how can we give say them whether strong acid, weak acid, okay. So types of acid we need to discuss, okay. There I will be explaining sulfuric acid is a strong acid and NH4OH is a weak base, okay. After reacting these two things, we are getting a salt, ammonium sulfate, and water is formed. So now this ammonium sulfate, what I am saying, this is a salt, okay. So salt, to this salt we are like along with that salt we have water also, right. So the resultant solution will become will be having some acidic nature. What I am saying, resultant solution will be having acidic nature. So this is what we will discuss in the higher studies, I mean in the higher classes. So just remember, whenever we are mixing equal quantities of strong acid and weak base, the resultant solution will be having salt plus water only. But due to the salt which is formed from the strong acid, the resultant solution will be showing acidic nature, okay. That is what the concept called acid hydrolysis, like salt hydrolysis. We will be studying about that later, just remember. Now I will be saying you one more example. So if you take strong base and we are treating with weak acid, now the resultant salt plus water will be having what nature? It will be having basic nature, okay. So this is why, because that whatever the salt formed, that will be getting hydrolyzed and forming again like some quantities of strong base. So due to that reason, solution will be having basic nature, okay. Hope it is clear, right. Let us discuss few more things here. Yes, so this is one of the very important topic or concepts which we are going to discuss now, the theories of acids and bases, okay. First theory we have Arrhenius acid base theory. So according to him, so just look here, so Arrhenius in 1884, he is a Swedish chemist. So what he is saying, so he is saying defines acids and bases as like this. See, acids are substances which dissociates in aqueous solution to give H plus ion. For example, here I have HCl I have, okay. Now when we place this in the water, aqueous medium, okay, so now it will releases what it is releases, H plus ion it will releases and forms H3O plus ion plus Cl minus, okay. So it is releasing one H plus ion, see, that is taken by the water. So simply I can represent this as, so H plus, okay, plus Cl minus. So both are these things are happening in the aqueous medium now, in the water now. So you just write aqueous, okay. Hope it is clear. Acids are substances dissociates in aqueous solution. It means he defined the his concept with respect to aqueous medium, okay. In the water it means, okay. So when we place in the water, it gives hydrogen ion, okay. So you can write H plus ion like this, or this is called hydronium ion, that is also correct, okay. Both represent resultant solution is having H plus ion in the solutions, okay. So here we have HNO3, HCl, these are the examples for acids, and sulfuric acid here we have, and this is called acetic acid. What is that? CH3COOH is acetic acid, that is also acid, but it is a weak acid, okay. We will discuss about strong acid, weak acid in the upcoming session. Just let us understand exactly what are the acid base theories we have and exactly how can we define acid and a base, okay. Up to here it is clear now. Now look here, bases are the substances which dissociates in aqueous solution to generate hydronium ion. For example, here we have NaOH, okay, upon upon placing this in the water, it will releases what? It will releases OH minus ions. So it will releases OH minus ions like this. Okay, from this OH minus ions are released. Okay, the concentration of OH minus ion increases in the aqueous medium. So that is what the that particular compound is considered as base. So here we have written now dissociates aqueous solution to generate hydroxide ion. So this also generates hydroxide ion here also, and this MgOH twice also generates 2 hydroxide ions. So that is also basic. CaOH is also similar. Okay, so this first line, this line are strong bases, and this is what? Weak base. This is a weak base. Okay, so NH4OH I am taking. So it in the aqueous medium, it will forms NH4 plus and OH minus ion is released. So here OH minus ion it is also releasing now. So this can be also considered as base. Okay, here we have Na plus ion also, aqueous. So OH minus ion concentration is increasing in the aqueous medium, therefore we are considering them as bases. Hope it is clear. Now if an acid and a base react, then that will be resulting to form salt plus water. We discussed about that, right? Okay. So here we have one more thing I am writing, acetic acid CH3COOH. So how it will dissociates in the water? So it will be giving acetate ion, sodium like this acetate ion, in the next H plus ion. See, H plus ion is increased, so H plus ions are released in the aqueous medium, therefore this particular compound is considered as acid. Hope it is clear. Here OH minus ions are released, therefore this compound is called as base. Hope it is released. It is clear about Arrhenius acid base theory. Okay, then next, what is the example application of this Arrhenius acid base theory? See, it explains the acidic nature of aqueous solution of non-metallic oxides. Okay, for example CO2 is there, this is a non-metallic oxide, and I am saying this as acidic oxide. So how can we know whether a compound, whether given oxide is acidic or basic? So when we place this particular oxide, or when we add water to this oxide, so it will be releasing acidic solution, or it is forming an acidic solution. So when we add this water to this, the resultant solution is called carbonic acid, H2CO3. This is an acid now. Okay, so it will be releases H plus ions, like it has 2 H plus ions now. It releases like this, H plus plus HCO3 minus. See, now the given compound, this whatever the resultant compound formed from this is releasing H plus ion. Therefore, I can call this as acidic solution. The compound as acid and the oxide as acidic oxide. Hope it is clear. Next, here we have sulfur dioxide, sulfur trioxide. Let us say sulfur trioxide is there. Okay, to this I am adding H2O. Look here, we are getting a very strong acid here. See, one sulfur is there. Yes, I am writing sulfur. 2 hydrogens are there. Yes, 2 hydrogens. Total 3 plus 1, 4. 4 oxygens are there. H2SO4. Sulfuric acid, king of chemicals, right? So we got sulfuric acid, which is strong acid. Therefore, if this is acid, the form, see, whenever we add an oxide to the water, if the resultant compound is an acid, as the resultant product is an acid, we can call this as acidic oxide. What is this? Acidic oxide. Hope it is clear, no? So acidic oxides upon hydrolysis forms oxo acids. So these are called oxo acids. Hope it is clear. Now basic oxides, similarly, when we say explain the basic nature of aqueous solutions of several substrates like metal hydrides, metal hydroxides. See, not only metal hydroxides, metal oxides also. For example, I am taking Na2O. Okay, so I am saying this is a basic oxide. So why I am saying this is a basic oxide? Basic oxides, okay, upon hydrolysis forms bases. Hydroxide forms hydroxides like this. See, NaOH 2 like NaOH, so 2 times. Okay, so this is what we got from the solution. We added Na2O to this water, so that resultant solution is a basic solution. Sodium hydroxide is formed. Therefore, I can call this as basic oxide. hope it is clear now. So basic oxides upon hydrolysis forms hydroxides. So hydroxides are nothing but they are basic solutions. So these are bases. Hope it is clear now. Yes. Next, Brownstein-Lewis acid base concept. Okay, see, this application is very important. So just tell me, I will be giving you one question here. So what is the product formed by hydrolysis of N2O5? What is the product formed by hydrolysis of this particular oxide N2O5? And also one more thing, so what is the product formed by calcium, hydrolysis of calcium hydroxide? These are the homework questions I am asking you, and you have to write in the comment box what are the products formed, so that I will be verifying your answers in the comment box. No issues, not at all, nothing to worry. So whether it is right or wrong, just give a try for answering these two questions. Okay, just hydrolyze them, write the respective products. 1, 2. These are the two things I am giving: calcium hydroxide and N2O5. These are the two things you can hydrolyze and tell me the answers. Okay. Then next here we have Brownstein-Lewis acid base concept. Okay. So what he is saying is, according to him, an acid is a substance which donates proton. So proton donor is an acid and proton acceptor is a base. So according to him, so proton means what? H plus ion. Okay, proton donor is an acid and proton acceptor is a base. That's it. If a particular substance donates proton, we can say that as acid. A particular substance accepts the proton, we can say it as base. For example, here I am writing HCl plus H2O, okay, and these are forming H3O plus and Cl minus. Okay, so if you observe this from here to here, this one and this one, see, this species donated its H plus ion and forming Cl minus ion. Therefore, this is a species which donated H plus now, so I can call it as acid. Okay, now proton acceptor. So this is a water molecule, this is a species which accepted this H plus ion and become H3O plus, right? So this is called, proton acceptor is called base, right? You can write here. Hope it is clear about up to here the basic thing. Okay, this is a basic definition about acid and base. Now one more example I am giving here. Now ammonia I am writing with again water only. Okay, so here see, I am writing ammonium hydroxide plus H plus. Okay, so why I have written this? Because there is one thing you need to observe here. In the first case, water accepted H plus from this acid and forming H3O plus ion. In this case, water is acted as a base, right? Water acted as base. But here, see, ammonia taken this OH minus ion. It means from water it is taken OH minus ion. It means taken OH. See, this is taken like NH4OH. No, sorry. See here, so we have ammonia, right? So it means it taken this H plus ion from water, and see in water what we have, H plus ion, OH minus, right? OH minus, no? So ammonia taking this H plus ion from here and forming, see, NH4 plus it is forming, along with that remaining OH minus also we added there. So in this case, ammonia is acting as, see, H plus like proton acceptor is what? Base. So this is our base and water is our acid. Okay, from these two reactions, what you need to consider, what I wanted to mention here is, in the first case water is acting as base, in the second case water is acting as acid. Okay, so depending upon the condition requirement, water showing its basic nature as well as acidic nature. So those species which can act as acid as well as base, we can call them as amphoteric substances. What is that? Amphoteric substances. So water is an example for amphoteric substance. Okay, I will give you few more example. Wait for some time. Need to discuss about this Brownstein acid base theory little more. Okay, the main advantage of this is that not restricted to neutral molecules. There are certain substances such as H2O, just now we discussed na H2O, and we can also say bicarbonate, this one, okay, HCO3 and HSO4 minus. So these are having capability to accept H plus or to donate H plus. Just now I told you water is there, so now water, by using this lone pair electrons, it can accept H plus as we seen in the first case and forming H3O plus now. So in this case water is acting as base by accepting this H plus, right. In the second case what we have seen, when it is reacting with ammonia, we have seen water is donating H plus. In that case it is, in this case it is acting as acid. So it means similar to that bicarbonate also it can donate this H plus or it can accept H plus by using this negative charge. Here also this H plus ion can be donated or H plus ion can be accepted by this particular HSO4 minus. So this kind of species which have ability to accept H plus or donate H plus can be considered as amphoteric substances, right. Hope it is clear up to here, and we'll need to discuss little more about Bronsted acid base theory. Okay, you can take a screenshots of all these notes, or you can make the notes very clearly. See, all this information I am providing just to make you feel to make yourself understand the things whatever I am discussing and make your own notes from the lecture. Okay, so that's why I am mentioning all these things in the screen, I mean in the slides. Okay, so here one more important thing is this one, conjugate acid base theory. Okay, so look here, and there are many questions on in JEE NEET also based on this particular topic, which is very basic and very easy to understand. Look at here very carefully, I will explain everything. Okay, in case of acid base reactions, in case of acid base reaction, the reverse reaction is also an acid base reaction. It means, for example, just now we have discussed HCl is an acid and ammonia. So which, see, according to the Bronsted-Lowry's acid base theory, what exactly an acid and a base? Proton donor is an acid. HCl will donate this H plus and ammonia will accept that H plus. Therefore, this is donating now, so I am writing it as acid. Okay, and this is accepting now, therefore I am writing it as base. Okay, now what are the resultant species we got from here? So we are getting NH4 plus, right, and Cl minus. Hope it is clear. Now see, this donated H plus that is taken by this and forming this respective things. Okay, so now here I am using a symbol which is reversible like this, just for understanding purpose. Now after forming this, let us imagine the reaction is starting here and we are coming this side, we are coming back. See, now this is donating H plus and this is taking that H plus. So this proton donor is what? Acid. So proton donor is what? Acid. According to acid base theory, that is what is proton like acid? Proton donor. So this is donating H plus and becoming ammonia. That is H plus is taken by Cl minus and forming HCl. So can I write this as acid? This is also acid. So for understanding purpose, I am writing acid 1, this is base 1, this is acid 2 and this is base 2. Why I am writing base 2? Because this H plus ion is accepted by the Cl minus only now. So that's why from, if we go from here to here, so this will be the base, this will be the acid. Hope it is clear, right? Now if we look from this side, so this is acid now. So from acid, whatever the negative part we get now, so we are saying it as base. So that base you should call it as conjugate base. What is that? Conjugate base. Okay, and base after accepting the H plus, it is forming acid now. So this should be called as conjugate acid. Hope it is clear what is conjugate acid base theory. Okay, now this is a acid releasing H plus forming negative part now. So that negative part is called base. What base exactly? Conjugate base. And this is accepting H plus and forming acid. That acid should be called as conjugate acid. Hope it is clear. Okay. Next, here always remember, I will be giving you little more extra information which you are going to study in higher standards, but now here itself I am explaining this. Okay. Now always remember, the conjugate acid of a, see this is a base, for base only now we are getting conjugate acid, the conjugate acid of a weak base is strong. For example, if I say this base is very weak, its respect to conjugate acid will be strong. That is what the line here it is indicating. Okay. Now similarly, the conjugate base of a weak acid is strong. It means if I take any acid which is weak acid, see conjugate base of a weak acid. Na? So if we take any weak acid after releasing H plus, then we will be getting the respective conjugate base, na? So that will be strong. Weak acid conjugate base will be strong. If this side is weak, that side will be strong. If that side will weak, this side will be strong. Okay, the next statement is that one only. For example, here we know HCl is a strong acid, then respect to conjugate base will be weak. Okay, the conjugate base of a weak acid is strong. We have written conjugate base of a strong acid will be strong acid is weak. Hope it is clear. If this is strong, if this acid is strong, its base will be weak, or if this is weak, its base will be strong. That is what I am saying. Hope it is clear, and I will show you few questions on this also. Wait for some time, which is asked on whatever we discuss. So if you want, let me check it now itself. So now just tell me that statements based, I will tell you what is the answer for question for that. Conjugate base of H3O plus, you tell me. So we have the conjugate H3O plus we have now. So what is its conjugate base? Okay, so if it is acid, by releasing H plus, we will be getting this one, no? So if this is the acid, then the respect to after releasing H plus, the remaining part we have now, that is what the base. Which base? Conjugate base. Okay, always remember acid and its conjugate base, this pair will be differ by one H plus ion. So always remember, this is a statement based question also. A base and its conjugate acid, or a conjugate acid or its conjugate base always differ by what? One H plus ion only. See here 3 hydrogens are there, 3 H plus ions we can say, but here only 2 are there. So one H plus ion is difference from here to here, na? So that is what you need to understand, and you can make a statement of it. Okay, so what is the conjugate base of H3O plus ion? So this will be the conjugate base. Hope it is clear now. Okay, now I will be asking you one question as a homework. In the comment box you need to answer. So I will be giving you water molecule. So what is its conjugate? See, if this is acid, what is its conjugate base? Okay, so you write in the comment box. Okay, see, this is really little, you need to think a little bit. You should keep you should avoid the confusion, so that that's why I am making these questions. If this is acid, what is its conjugate base? If this is the base, what is its conjugate acid? So these are the two questions, 1 and 2. Okay, you need to answer in the comment box. I will be expecting answer from you for these two questions. Okay, and the next thing is we need to discuss about Lewis acid base concept also. Okay, and here I told now, see, if one is strong, if acid is strong, its conjugate base is weak, I told now. For example, here I am saying, see, I have HClO4 and I have HClO3. Okay, so in this, now here itself I am saying this is a strong acid. So one is stronger than 2. Okay, one is stronger than 2. Okay, you can remember like that. If this is a strong acid, respect to conjugate base is what? Just remove H plus ion from here. So just remove H plus ion from here. So what we'll get? So we'll get, if we remove H plus ion, we'll get CO4 minus. So if this is a acid and this will be its conjugate base, and from this also if H plus ion is released, so we will be having ClO3 minus, right? This is a conjugate base. So what I told you, out of these two, HClO4 is stronger acid than HClO3, right? This is the acidic nature I told you. Now what about its basic nature of conjugate bases? So it will be reverse of this. It means ClO3 minus will be stronger base than ClO4 minus. This is what you can understand from these three statements. Okay. The next thing is Lewis acid base concept. Okay, what is this? Okay. So here, according to this Lewis acid base theory, so acid is a substance which accepts a electron pair, and base is a substance which donate a pair of electrons. Okay, I will tell you exactly. So acids are electron deficient species, so they are seeking, or they require electrons to accept. Okay. So in order to fulfill the electronic configuration, or in order to make their electronic deficiency to fulfill, they will accept a pair of electrons. So that those substances which are accepting pair of electrons can be considered as Lewis acids, and those substances which are releasing or which are donating pair of electrons are called as Lewis bases. Okay. Now here if we say, I am writing here ammonia, I am writing NH3. Now it is having pair of electrons like this. Here I am writing BCl3. Okay. Now on this boron we will be having one vacant orbital. See, if I write the structure of boron here, like BCl3, sorry, not boron, BCl3, it will be like this. Okay. So how many electrons are there here in these? 1, 2, 3, 4, 5, 6 electrons only there. So on this boron we have 2 electron deficiency. It means in order to fill the electrons, completely fill the electrons of this boron, we require 8 electrons. That is what octet rule we are saying now. So but the 8 electrons are not there, only 6 electrons are there. So one empty orbital will be there. So to that, the lone pair electrons of this nitrogen will be donated like this. Okay, and it will be forming BCl3 and NH3 complex, like this it will be forming. Okay. So now this bond is nothing but just to donate the electrons from here to here, it is donating, that is the symbolic representation, and this kind of bonds are called dative bonds or coordinate covalent bonds we can say. Okay. So now this is a species which is donating pair of electrons now, so we can call it as Lewis base, and this is accepting the pair of electron, so Lewis acid. So this is a concept of Lewis acid base theory. Okay. Next, so what I told you, acids are electron deficient, and this can be neutral and this can be positively charged. Okay. So when how can we identify a neutral compound is Lewis act as Lewis acid or not? Just count the number of electrons. If it is having electron deficiency, then it can accept the electrons, so that we can consider it as Lewis acid. Okay, like BCl3, BF3, FeCl3, AlCl3 considered as Lewis acids. Okay, and some simple cations like H plus, like Ag plus, Fe plus, Cu plus 2. So these are what? Lewis acids. Okay, they are also having electron deficiency, right? And the next, chemical species which can act as Lewis bases. So let us see here what I told you. These are electron pair donors now. So these should be having electron rich. Means there should be non-bonding electrons at least, or they should have negative charge. Negative charge is nothing but more electron density only na. So that can also be donated. Okay. So at least one pair of lone pair of electrons should be present, like on ammonia I have shown you, on water molecule, on alcohols and on amines, right? Next, all negatively charged species like Cn minus, OH minus, Cl minus, X minus you can consider. Okay, X can be generalized one. Okay, anything with negative charge can be considered as Lewis base here. Okay, so these are the generalized statements and examples. Hope it is also clear now. So let us look into 2 questions. So this is done, and one question we have: what is the conjugate base of hydrochloric acid? So chloric acid, I just now told you HClO3 is a chloric acid. So just remove H plus ion, it will be forming ClO3 minus. So if this is acid, then this will be the respective conjugate base. That's it. That is what the answer you can answer. Okay. Then next, one last question here we have. Ammonia is a Lewis base. Why it is? Because Yes, tell me. Ammonia is a Lewis base. What is the basic definition of Lewis bases? Electron pair donors are Lewis bases, right? So electron pair donor, yes, that's it. So your answer is 1, that's it. So if Lewis acids they are asking, electron pair acceptor you should say. So hope you got clarity on this kind of questions. See, all these questions which I have discussed at the end of this session are purely PYQs, okay, of different exams, like maybe some related to engineering entrance exams, some related to medical entrance exam also, okay. I hope the session really went well, and if you really like the content, just click on the like button, and also you can share with your friends, and you can answer them in the comment box. I will be waiting for your answers. So thank you for watching. Keep learning. Thank you.